All right, the next book we're going to read is Animals in Flight, written by Steve Jenkins and illustrated by, actually it's written by Steve Jenkins and Robin Page. And I learned, as I was previewing this book, and if I read on the back cover, I'll read you a quick little blurb. It says, they collaborated on their book, What Do You Do with a Tale Like This? In addition to this book of Animals in Flight. And they both live in Boulder, Colorado with their 3 children. So by saying that, it makes me believe, and they are, is that they're married, okay? So it's kind of cool they get to write together. So we're going to read Animals in Flight. And you probably don't think much about how birds or insects fly, but this book might just get you to pay attention a little closer. And when we see the front and back cover, you see a full spread of a bird's wings. So we are going to get started. And this is all about flying birds or flying animals. Imagine being able to fly. Soaring, swooping, diving, and hovering. So many animals are able to do what we can only dream about. How do they do it? When and why did they take to the air? This is a barn swallow. A fast and graceful flyer spends up to 18 hours a day in the air. I can remember those on my grandpa's farm. Insects were the first flying animals. The ancient dragonfly lived almost 350 million years ago. Larger than any insect alive today, it had wings measuring 2.5 feet across. Now remember, your foot from here to about here. That would be about a foot. So 2 of those. That's a pretty big insect. How did insects begin to fly? No one knows for sure. Some insects may have had flaps on their bodies that they used to warm themselves in the sun. Or they may have started their lives in the water and had fins for swimming. When these insects jumped to avoid danger, some were able to glide to safety with the help of these fins or flaps. After a few million years, most insects had developed real wings and had spread it to all parts of the earth. One of these insects, the ancient cockroach, was 1.5 feet long. Well, you know how Mrs. King feels about cockroaches, so could you imagine if I came across one of those? Oh, it wouldn't be pretty. We'd be calling Mrs. Minger to come and rescue us. Then, about 250 million years ago, small dinosaurs began to fly. The first flying reptiles were small animals that were related to dinosaurs and lived in trees. Eventually, some of them became quite large. The Pteranodon, which lived 175 million years ago, had a 17-foot wingspan. The Archaeopteryx, which lived 150 million years ago, was the first true bird. It had feathered wings and scaly skin like a reptile's. The largest of the flying reptiles was the Quetzalcoatlus. Its wings were 40 feet across. The modern-day bald eagle has a wingspan of about 7 feet. Flying helps animals escape danger, find and catch food, and move from place to place. A robin uses flight to escape danger. It may also fly to catch insects, to reach seeds or fruit that other animals can't get to, or to find a safe spot to build a nest for its young. Here you see, the barn owl's wings are covered with soft feathers that make no sound as the owl swoops down silently on an unsuspecting mouse. All flying animals, past or present, have wings. Now there's different animals have different kinds of wings, but they all work by creating lift. So we're going to go through some of these wings. Here you have the reptile wing and the insect wing, the bird wing, the bat wing. And they're all just slightly different in shape. Lift is the force that gets an animal up into the air. All wings, animal or man-made, create lift in the same way. The shape of a wing causes the air moving above it to travel faster than the air passing below it. As the air moves faster, its pressure is reduced. This results in higher air pressure beneath the wing that pushes upward, lifting the wing and the flyer into the air. And this wing we see here, this is the wing of a scarlet macaw. And remember, scarlet is a shade of red. That's another word for red, or a variety of red. Animals use their wings in different ways. Some can hover. Most insects can fly like a hummingbird. When a housefly wants to land on the ceiling, it hovers right side up, lifts its front leg until its feet touch the surface, then swings its body around so it is upside down. The hummingbird is the only bird that can hover or fly in place. Hummingbirds can also fly up, down, sideways, and backwards. And over here you're going to see the hummingbird's wings can act as helicopter blades, pushing air down or sideways. This is how the hummingbird can fly in any direction. Others can dive, soar, or turn loops in the air. Ducks often travel in a V formation, except for the leader. Each duck is partially pulled along by the air currents created by the bird it flies behind. It takes more work to fly at the front of the V, so the ducks take turns leading. And they will alternate. The front duck will go to the back, and then a new leader will take the place. Now this here is the peregrine falcon, the fastest bird of all. It can reach speeds of 175 miles per hour in a dive. That's pretty fast. Soaring birds like the vulture ride updrafts or rising currents of warm air called thermals. These birds may be able to stay aloft for hours without ever flapping their wings, which are large for their bodies. And then a bat. Bats have very flexible wings that allow them to change direction quickly. Most bats feed on flying insects, so they have to be acrobatic flyers. They can fly upside down, spin, or turn loops in the air. Birds use more than just their wings to fly. In fact, their whole bodies are made for flight. And here, this hawk prepares for a landing. And let's look at some of the parts here. It says, feathers light and strong create a large wing surface to push against the air. They also keep the bird warm to conserve energy. Hollow bones keep the bird's body light. Strong muscle power wings. And a streamlined body moves easily through the air. Now, what do we know about the ostrich and the penguin? Think about what you already might know. Yeah, some birds are unable to fly because they are too heavy or their wings are too small. These birds are able to get around in other ways. The ostrich, which can weigh as much as 300 pounds, can run as fast as a horse. The penguin is a graceful swimmer and spends most of its time in the water. Insects are the most common flyers. It's believed that there are more than 1 million different kinds of flying insects. And the honeybee, like most insects, has 2 pairs of wings. When a wasp begins to fly, which you can't see, my fingers are covering it, sorry. Its wings move down and forward like a bird's to create lift. As a wasp raises them for the next stroke, however, they twist upside down. This provides a lift on both the upstroke and the downstroke. When a butterfly is resting, you guys know this, it holds its wings upright and together. When it is ready to take off, it rapidly pulls its wings down and apart. This creates suction that pulls the butterfly straight up into the air. The ladybug, like all beetles, has a pair of front wings that are hardened into a protective covering. When the ladybug flies, it swings these hardened wings outward and forward and beats its back wings. The front wings don't flap, but they do provide lift once the ladybug is moving. Bats are the only mammals that can fly. The vampire bat feeds at night on the blood of other animals. The bat's wings are supported by 4 very long fingers. These flexible fingers and the thin skin stretched over them allow the bat to twist its wings into almost any shape, making it possible for the bat to change direction quickly and gracefully. Flying squirrels, flying fish, and flying frogs can't really fly. They are gliders. And here, this flying frog uses the skin stretched between its toes to glide from tree to tree. Like other gliders, it doesn't have wings and is unable to create enough lift to overcome gravity, so it is not a true flyer. Most gliders can travel from 50 to 150 feet in the air. The flying fish holds the animal gliding record of 1/4 of a mile, more than 1,300 feet. We have the flying squirrel, the flying lizard, the flying gecko, the flying fish, and the flying snake. The largest and smallest flyers. This here is the albatross uses its large wings to soar over the ocean for days at a time. Now look at that tiny thing. You see it there? This is the fairy fly. It's only 1 1/125th of an inch long, and it is the smallest flying insect. Next is the bumblebee bat, the world's tiniest bat. It has a wingspan of 6 inches and weighs less than a penny. Here at the end is the bee hummingbird. It's the smallest bird. Its body is less than 3 inches long, and its wings measure 6 inches across. Now the largest flying insect is the Queen Alexandra's birdwing butterfly. It measures 12.5 inches from wing tip to wing tip. Remember, 12.5 inches. Well, 12 inches is a foot. Imagine, oops, sorry, I knocked my camera. Now, the Indian flying fox with wings 6 feet across is the largest bat in the world. And finally, the albatross has a wingspan of up to 12 feet, the largest of any bird. Fastest, farthest, highest world record flyers. The spine-tailed swift is the fastest bird in level flight, not in a dive. It can reach speeds of 112 miles per hour for short periods. That means it can't keep that speed for very long, but it's also not diving down to reach that speed. Now the horsefly can reach speeds of 30 miles per hour or more, making it the fastest insect. The spotted whooper swan holds the record for high altitude flying. It's been seen flying 27,000 feet above sea level. The fastest bat, the big brown bat, can fly at 40 miles per hour. We know this one. The monarch butterflies migrate from the Great Lakes to Mexico every fall, a distance of over 2,000 miles. And the Arctic tern flies a round-trip distance of 25,000 miles every year as it migrates from the Arctic to the Antarctic and back. That was the Arctic tern that does that. Inspired by animals, humans have dreamed of flying for centuries. An early unsuccessful flying machine as seen in this picture. That's what the caption says. Unlike birds, human bodies are not made for flight. A man of average weight, 150 pounds, would need wings about 140 feet across to fly successfully. Even the strongest man would be unable to flap wings so large. But that hasn't stopped him from trying at times. Here you see the helicopter, or this helicopter built in the 1800s didn't work because it is very difficult for a human to generate enough power to lift his body into the air. Now, the first human flights were made using balloons. In 1903, the Wright brothers piloted the first working airplane. It traveled just 120 feet in its initial flight. A modern passenger jet flies at speeds of more than 500 miles per hour. And the fastest plane is the SR-71 Blackbird spy plane. It was built by the United States in 1961 and can fly 3 times the speed of sound, over 2,000 miles per hour. The end. So now we know about animals in flight.